and welcome to the Spatial Structures Movers and Shakers interview series, as we look ahead to the ISS Annual Symposium and Spatial Structures Conference taking place at the University of Surrey in August 2021. My name's Mark Richardson, and today I'm joined by Carlos Lazaro, who is an Associate Professor at the Universitat Politécnica de Valencia. Carlos is also a Vice President of the ISS and the Chair of the Technical Activities Committee. Thanks for taking the time to speak to us today, Carlos.
Thank you very much, Mark. It's my pleasure to be here, and thank you for the invitation.
No problem. It's wonderful to speak to you on the series. We're beginning the series by asking, how have you been finding the lockdown period, and how's that been for you in Valencia?
Well, so now, after more than 3 months lockdown, we have started at the university again. But with no students. So it's kind of a strange feeling because the university is quite empty, but we have got a certain amount of normality there. And the lockdown at home has been long. Working from home seems nice at the start, but after some months, you miss a lot the contact with your colleagues and also with the students. And of course, this situation, this COVID pandemics, we have to see how to help mitigating the consequences of this crisis as soon as possible. Yeah.
Thanks, Carlos. That's great. Yeah, and a similar situation to what's been happening in the UK where we're recording from. Maybe you could tell us a little bit more about your career to date. We're exploring the careers of all of our participants on the series as well.
Yes, of course. So I studied civil engineering in the 1980s, and at that time in Spain, it was a 6-year long program, a kind of combined bachelor plus master studies, and with a strong background in maths and in physics. And then after my studies, I started working in Barcelona for 1 year and in Berlin in Germany for 2 years, and then came back to Valencia. And so those experiences in Barcelona and in Berlin were very special for me. In Barcelona, it was the year right before the Olympics, and in Berlin, it was not long after the reunification. So there, and in the start of my career, I worked as an engineer, in project engineer, and I specialized in structures, but I worked not only in the realm of structures. And then about the year 2000, I became a partner of a design office, CMD, with a colleague of mine, Alberto Domingo, and we had the opportunity to design and participate in many interesting structures for buildings and bridges, not only in Spain, but also in other countries. And regarding my academic career, so I started teaching at the Universitat Politécnica de Valencia more than 20 years ago. And there I work closely with Professor Salvador Monleón, who is an exceptionally talented bridge designer and also an expert on beam and shell models. And I got my interest and my love for analytical techniques from him. And currently I am an associate professor of structural mechanics at the School of Civil Engineering, and I teach courses on theory of structures, philosophy of structures, bridge engineering, and for bachelor and master students. And so currently, I am fully focused in my activity at the university, teaching and also research. And I would like to say that I have recently started a collaboration with the Chair of Structural Analysis of the Technical University in Munich, and we are working on mitigation of wind vibration in bridges. And of course, I am also very involved in the IASS, the International Association for Shell and Spatial Structures. And as you said, I am one of the vice presidents and chair of the Technical Activities Committee. And this is something I am happy to participate in.
Thank you, Carlos. And in the previous interview in this series, we spoke to Juan Gerardo Olivia Salinas about his work with Fray Otto. You've also worked with some of the most respected names in the field of spatial structures. I was wondering if you could tell us about your experience of working in collaboration with Mamoru Kawaguchi.
Sure. So I had the privilege to work with the late Professor Mamoru Kawaguchi in two projects, one in Spain, near Valencia. It was a circular roof with a span of 80 meters, built with the Pantadome system, invented by Professor Kawaguchi. And the other one was a large glazed dome for a public building in Georgia, near the Black Sea. And in those two projects, I've learned a lot. But Mamoru Kawaguchi has been always a professional reference for me, because as a young engineer in Barcelona, I knew that he designed one of the buildings for the Barcelona Olympics, the Palau Sant Jordi. And this was a kind of example for me. And I listened to one of his lectures first in 1999 at the one of the ISS conferences, and I could appreciate the way he designed his structures, or he conceived his structures, which was very much inspired by physical principles. He worked a lot with physical models and built physical models. And I also co-organized an exhibition on Mamoru Kawaguchi during the ISS 2009 symposium in Valencia, where all those models were exhibited. He was an incredible pioneer in the field of lightweight structures, not only because of the Pantadome system, but also because of the inflatable structures and also other structural systems like timber steel hybrids. And one of the things that most impressed me working with him was the time and the effort he devoted to the conceptual phase of structures, and how this clear understanding of the way that a structural system must work was one of the most important things in the design. And recently he passed away, so around 1 year ago. And I wrote an article on his work in the International Journal of Space Structures. And as I say in the article, I think that he will continue to be very inspiring for future generations of engineers and also architects.
Thanks very much, Carlos. That was a wonderful overview of Mamoru Kawaguchi and his career. Thank you for sharing that with us. So we're now moving on to the middle section of our interview, Your Space, Your Structure, where Carlos will be taking us through a project that he has been involved in his career in the past. And for this section, Carlos has selected the last thin shell concrete structure conceived by another icon of the spatial structures world, Felix Candela, the l'Océanographique project, which Carlos will be kindly telling us about his experience working on. So over to you, Carlos.
Okay, I'm going to share my screen, and I would like to talk about this structure. This is the roof of the restaurant in l'Océanographique, which is the aquarium in Valencia. And as you can see, this is a thin shell structure, which is very much inspired, or even can be considered the last work of the Spanish-Mexican architect Felix Candela. And this is a classical picture of Felix Candela. He is a very famous personality, and very well known by the shells that he built in Mexico, mostly in Mexico, but also in other American countries and also in Spain. And the structure in Valencia was inspired by this famous Los Manantiales shell built in Xochimilco in Mexico City in the 50s by Candela. Candela participated in the design of the l'Oceanographic, but he passed away in 1997 before the design was complete. And he suggested to make a reproduction in Valencia of this Mexican shell, which is possibly one of the most well-known shells of him. And it represents very well his philosophy for building structures. He used very thin reinforced concrete in this shell. It was a 4 centimeter thin shell. Many of his structures have the shape of a hyperbolic paraboloid, and hyperbolic paraboloids are doubly curved surfaces that provide a very good load distribution and also a high buckling resistance. And they have also another important feature which benefits the construction process. They are ruled surfaces, and this fact makes quite easy, or is quite convenient to build the framework of the shell. And Candela shells were built by his own company, Cubierta Sala, and it was a highly specialized company. The only activity was to build thin shells, and therefore he developed a very efficient process to build these shells. And for the shell in Valencia, I would like to mention that this was, of course, a teamwork with the colleague I mentioned before, with Roberto Domingo, and also Enrique Català, a young engineer at that time, participated in the project, and we got the advice of Professor Pedro Serna, who is a specialist on fiber reinforced concrete. And so in order to design or make real this last Candela shell, of course we needed to respect Candela's philosophy of building shells. It was clear that the shape was defined, it was clear. It is not exactly the same size as Los Manantiales, but it is very similar. The distance between opposite supports is about 36 meters, and the height of the lobes, of the tip of the lobes, is around 12 meters. And we should make a shell as thin as possible, and we got to the minimum allowed thickness at that time, which was 6 centimeters. This was the minimum allowed by the Spanish code in 1998. And of course, we wanted also to use the advantage of the ruled surface, and you can see here air picture of the scaffolding and the formwork, which was supported on the generatrix lines of the ruled surface. The thickness of the structure, we checked also other possibilities to make it thicker, but it was clear that making it thicker was not helping the design. What was the main challenge that we have to overcome? So the main challenge is how to make building of this kind of structure possible in the year 2000, because the time of concrete shells was over. Construction companies were not used to build these kind of structures, and also the codes has changed a lot since the time of Candela. So Candela built with practically no codes, And of course, we needed to check the safety of the shell. And for that, we needed to prepare a finite element model. And the problem with this finite element model is that it takes into account this phenomenon of bending of the shell, which was not considered by Candela, who made his calculations with the membrane theory. But when you use finite elements, you get bending moments, which are not very big, but need to be resisted. And we had to figure out how to solve this problem and also how to make possible the construction with a different technique using much less people. And our answer to this problem was to use steel fibers in the concrete mixture. And these steel fibers provided the necessary strength against bending, also provided ductility, and in combination with shotcrete, with projected concrete, allowed to build the structure without having a lot of people climbing up the formwork, and of course in a more safe manner. This was the final result. And as you can see, this is before the glazing, and it's a very light structure with free edges, no beams on the edges, thanks to Candela's idea. So this is the shape of Candela's, is kind of reproducing the shape, but bringing the modern technologies of the year 2000 in order to make construction viable and also economic. And I would like to, before finishing, I would like first to show also the interior of the shell, because it is very nice to see the groins, also to see the texture of the concrete. The picture was taken during the ISS symposium in Valencia in 2009, and I am happy to see it again. And I had the opportunity, after participating in this project, to travel to Mexico for 2 times. The first time was on the occasion of the symposium organized by Juan Gerardo Oliva, and then invited by Juan Ignacio del Cueto, who is a specialist on Candela's works in Mexico. And there I have seen some of Candela's works, and also listen to people who work closely with him. And I find that it really admirable the way he designed his shells. And therefore, for an exhibition that was organized by a colleague of mine last year, with the topic concrete shells in the Valencian region, I was asked to write some text about this structure, and I found that it was meaningful for me to try to reproduce the way in which Candela designed his shell and apply it to the shell of l'Oceanographic. So I rescued the material that Candela left to us, so his articles and papers, and really used the same procedure that he used to design the shell, and found that it was a completely efficient procedure. He had studied the German masters of shells, shell theory, membrane theory, and he had found his own way to check and to design shells with free edges. And this was one of his main breakthroughs. And I reproduced this process with my computer, and this is the graphical result. No finite elements, so this is just membrane theory. It is very beautiful, and it summarizes maybe the main points that we can get out of this work. Is the example of Candela, how to improve the design, how to make a clever design, to use less material, to take advantage of the environment of the building industry in your environment. And also it was the way to show that shells can be built also in the year 2000. This is one way to do it, and there are of course many other ways and many other shells being built now, as Sigrid Adriansens told us in another interview. And yeah, that was the structure I wanted to present. So I thought of maybe showing another structures I participated in, but I thought that after this one, it was not it's so beautiful that I think it's good to leave it here.
Thank you very much, Carlos. That was wonderful. Moving on to ISS 2021, which this series is here to help promote. What do you anticipate will be hot topics as we move towards the ISS 2021 conference?
Yes, so as you know, I was one of the organizers of ISS 2019 in Barcelona last year. And if you look at the contributions of Barcelona 2019, they were very well distributed among a lot of topics. But in the ISS symposia, there are always star topics or trending topics. And usually there are many contributions related to structural morphology in a wide sense, related to shaping structures, form finding, optimization. This has to do also with computation. But I was surprised to see that there were many contributions devoted to advanced manufacturing, new manufacturing techniques, digital fabrication, non-standard materials. And I think that this will be one of the probably one of the important topics in ISS 2021. And the reason, so in my opinion, it is because there has been a strong change in the way we design structures compared to the historical way. If you look back at the history of structures since the Industrial Revolution, generally speaking, the Industrial Revolution brought new materials, metallic materials, first cast iron, iron, steel, later reinforced concrete. And the experience of engineers using these, at the time, new materials refined the shape of the structures or the morphology of the structures in a sort of trial and error process. But nowadays, things have completely changed. So we have incredible tools for form finding, for making computational form finding, for optimizing the shapes. So if you look at many contributions in past ISS symposia, you see that there are possibilities, also cheap possibilities at hand of architects and engineers to make possible very complex shapes that are also logical in terms of strength. Not just crazy shapes, but complex shapes that have also structural logic. And the challenge then is not, is reverse, is which is the material I have to use in order to build that? And this question has not a single answer. So there are many possible answers. And in these manifold answers lies the explanation why this advanced manufacturing, new materials is something which is probably one of the interesting topics in next year's conference.
That's great. Thank you, Carlos. And we also have a question from an audience participant. A person called Adrian via LinkedIn has asked the following question. What do you think is the most innovative and promising technology in the lightweight engineering industry?
Well, so that's very hard to say, basically because of the what I explained before, because there is no a single answer to that question. So imagine that we are thinking at the same time of providing structures in countries where the population is forcing to grow very rapidly. And then we need solutions that maybe for places where there is not a big industry in construction. And we need solutions that require to reduce carbon footprint, use of natural materials like bio-based materials. And we are also in a completely different way thinking on building things in Mars. And of course, then in Mars, you need to use robots to build something. And of course, you can also use robots to build something here. So the present times bring us a full range of possibilities of building in new ways that are better than the traditional ways, or that can take advantage of traditional techniques with new shapes, better shapes. And there is no single answer to that question. So I think the answer is it has to adapt to local conditions. And for every local condition, there is an answer to that.
Makes sense. Well, thanks very much for taking us through that one, Carlos. And thank you indeed for being a guest on the Movers and Shakers interview series. It was wonderful to speak to you today. We've been through some very interesting and fascinating projects. Thank you again for taking the time to talk to us, and hopefully we can catch up with you again later on as we move towards the ISS 2021 conference and have another chat with you in the Movers and Shakers interview series. Thank you, Carlos.
Thank you very much, Mark. It was a pleasure.